And then the next thing we could do is potentially, when we've got an image we're really happy with and we think we want to do a deeper diagnostics, we can hit the actual frame capture. And that will grab everything that's on the screen and store it in a file. Now what I'll do, I'll shut this one down and I'll open up a file that we created earlier. And this actually comes from Civ 5. So what we have now is these are all the DirectX calls that were actually used to create that frame. We can see a little miniaturized copy of the image down here in the bottom left-hand corner. If I click on any of these, we can actually see what part of the image was affected by that particular draw call. And you can see the time it took. So in this particular case, that took 2.5 milliseconds to draw the character's body. We have one other call that was particularly expensive, and everything else is underneath a millisecond. So once we've done that, we can start getting some experimental things. So we could actually look at the image, and I'll draw it in a big screen so you can see it. This is the overdraw, so we can see all the things that affect all the pixels on the screen. It's a way to find out if there's a potential optimization, because we think we might be drawing things behind objects that have occluded them. So what we can do is look at the pixel history. So we can point at any part of that particular scene, click on it, and we get a list of all the individual draw calls that actually affected that pixel I was pointing at. And I can select any one of these, and you can start to see, I remove the overdraw so it's a bit more obvious, that on that particular thing, I was looking at the saddle on the horse. If I move down, that pixel was also affected by the cloth that was underneath the saddle. And all of these draw calls that have been X'd out, when they actually came to draw, it turned out there was an object already there and the Z buffer said, I don't need to draw it. So I can see everything. For any one of these calls, if I click on it, I can get all the detailed metrics for how long it took. We can see all the textures that we needed to draw it. We can even see the shader code that was there for the vertex shader or the pixel shader. And if we want to, we can modify this in real time and reload the file. So we can do experiments. Another form of experiments we can do is we can actually disable the argument. And we can see what the image would look like without actually drawing it. And it will tell us how fast the actual frame is. So for a typical game, you might be able to quickly ascertain if there are certain effects that are taking a disproportionate amount of the time, in which case you could look at optimizing them. You could find out if some objects were so small they didn't contribute to what you could see. And again, you could potentially change your culling algorithms. So that covers a lot of the frame analyzer. You can add your own metrics. So as you can see here, it's been labeled up. So you can actually say that all the draw calls between 84 and a few hundred were actually the base pass for the opaque objects.